Yes, children. Let's further move with third group analysis. Third group is having aluminium and iron 2 plus and iron 3 plus. Okay. And what are the group reagents? Ammonium chloride and ammonium hydroxide. And all these ions, they get precipitated as their hydroxides. Okay. Now what are the reagents? NH4Cl, NH4OH, strong electrolyte, weak electrolyte. Weak electrolyte will be in dynamic equilibrium. And here you find ammonium ion is the common ion. So presence of common ion, what it will do? This will revert the second equation. This will go in the backward direction. Okay. So when it is moving in the backward direction, the presence of OH minus will decrease, or you can say it will be very less in the medium. Okay. So when it is less in the medium, then you may be wondering how they are getting precipitated as hydroxides. That is because the Ksp value of the hydroxides of these three is low. So whatever OH minus that is present in the medium and the presence of Al3 plus, concentration of Al3 plus or Fe2 plus, the ionic product of these hydroxides will exceed the Ksp value. So they will get precipitated. It's the same concept similar to that of your second group, right? OH minus ion concentration, even though it is less, it is sufficient enough to precipitate aluminium or Fe in the form of their hydroxides, because these hydroxides, they have a low Ksp value. So ionic product will definitely exceed the Ksp, so it will get precipitated, right? Okay. Now let's come to fourth group analysis. In the fourth group, you have zinc, manganese, nickel and cobalt in their respective oxidation states. Group reagents are NH4Cl, NH4OH and H2S. Now here, one strong electrolyte and two weak electrolytes are utilized. This will undergo complete dissociation. These two will undergo partial dissociation, or they will be in equilibrium, giving rise to ammonium ion and hydroxyl ion and H plus and S2 minus. Okay. Now in the medium, H plus and OH minus both are there. So obviously it will become water, right? That means OH minus is not available to get precipitated as hydroxide. So these ions, how they are going to get precipitated? They are going to get precipitated as their sulfides. Okay. Now if H plus and OH minus when it combines to form water, then to produce more and more H plus, you may think that this H2S will ionize further. So the extent of sulfide ion present in the medium is a little more, because this OH minus will react with H plus, forcing H2S to produce more and more of H plus. You have studied according to Chatelier principle. If anything is removed, then the reaction shifts in that direction to produce that. तो इसको अगर निकालोगे, इसकी प्रोडक्शन ज़्यादा होने के लिए रिएक्शन फॉरवर्ड में जाएगी, तो S2 माइनस की कॉन्सेंट्रेशन बढ़ेगा. ठीक है. एंड द Ksp ऑफ sulfides, they are slightly on the higher side. That is why this S2 minus production is favored, so that the ionic product of these sulfides exceed the Ksp values. Okay? Ksp values of sulfides of these ions, they are slightly on the higher side. So the ionic product, in order to exceed that Ksp, more of sulfide ion is needed. That is why this NH4OH and H2S both are there, so that S2 minus production is increased. Okay, so that is the reason why both of them are added, right? Okay.